Ever feel like someone's watching you?
Yeah.
Well, imagine being a ship trying to slip by, like lights off, no signals.
Trying to be sneaky, sneaky.
Exactly.
Ugh.
But then, bam, busted.
Oh, no.
And get this, busted by nothing more than, like, the trail you leave in the water.
No way.
That's right. Today, we're diving deep into the world of ship wake detection.
Cool.
You sent over some seriously cool research on this, let me tell you. It's way more fascinating than I ever imagined.
It's like the ocean has its own, like, gossip network, those ships. Terrible at keeping secrets.
Exactly. We're talking about the science of, like, spotting and decoding these watery
I
fingerprints.
like that, watery fingerprints.
Our main source today is this paper, Review of Current Perspectives and Emerging Trends in Ship Wake Detection.
Catchy.
Now, I know that sounds a bit, technical, but stick with us. The authors, Ortiz Abuja and their team,
Okay.
they lay out how scientists, and even, get this, the Navy,
Whoa, really?
are using ship weight to reveal what's happening out at sea.
Wow. So even when these vessels go dark, like they're trying to avoid detection by turning off their tracking systems. It's
Right.
like they're trying to whisper a secret, but the waves just won't stay quiet.
Okay, so before we get to, like, the cloak and dagger stuff,
Okay, okay.
let's start with the basics. What exactly are we talking about when we say ship wake? I mean, we've all seen those foamy lines trailing behind boats,
Right, right.
but I have a feeling there's more to it than meets the eye.
Oh, you're absolutely right. It's not just about the bubbly white stuff on the surface. A ship wake is actually made up of different components, each whispering its own part of the story.
Yeah.
You've got the turbulent wake, which is the most obvious, that churning water directly behind the ship.
Right.
Then there's the Kelvin wake, that picture-perfect V shape spreading out from the sides.
Oh, yeah. Those Kelvin wakes are always so mesmerizing. Like those aerial photos you see of ships just cutting through the ocean.
Exactly. And each of these components, they form differently. The size of the ship, how fast it's going, even the depth of the water, they all play a role.
Interesting.
It's like each wake has its own, like, unique fingerprint telling a tale about the vessel that created it.
So wait, just from looking at these wakes, we can tell a lot about the ship itself.
You got it.
Now, that's what I call a clue.
Yeah,
Have you ever actually seen these wake patterns yourself?
Yeah.
Out on a boat or...
definitely. And I bet you have too. Next time you're on a plane, that's flying over water, take a look out the window.
Okay.
You might be surprised by what you see. It's like the ocean is communicating in a secret code.
Now that you mention it, I actually have seen those patterns.
Right?
Mind blown. It's like we're just starting to understand this whole other language going on right beneath our noses. Or I guess boats.
That's a great way to put it. And for the longest time, that's basically how we deciphered this language, just by looking and observing.
Speaking of which, I was amazed to read that scientists have been studying wakes for ages. This paper even mentioned the guy named Froude doing this back in 1877. Can you believe it?
Wow.
Talk about, like, old school oceanography.
William Froude was ahead of his time, that's for sure. His work on fluid dynamics and how ships move through water,
Yeah.
absolutely groundbreaking.
It's incredible to think that something we consider, like, high-tech today has roots that go back that far.
I know.
But, like, with so many things, technology has completely changed the game, right? So we've gone from, like, squinting at the sea to, like having a whole arsenal of high-tech tools at our disposal. Tell me, we've got lasers and satellites and, like, underwater microphones spying on these ships.
Okay, maybe not lasers and microphones,
Okay.
but we're not far off. This paper does a really cool job of, like, breaking down these different wake detection methods, from the classic to the cutting edge.
All right, I'm all ears. Give me the rundown on how we go from, that's a funny looking wave, to, gotcha. We know what you're up to.
So first you've got your classic methods, which are still incredibly useful today.
Okay.
One is called the radon transform. Now, stick with me here.
Okay.
I promise it's cooler than it sounds. Imagine you're trying to find a specific book
Okay, yeah.
on a bookshelf crammed full of different titles. The radon transform is like having a magical tool that scans the shelf and makes the book you're looking for jump out, highlighting those straight lines that make up the Kelvin wake, even when they're surrounded by clutter.
Okay. I can see how that would be super helpful,
M-
especially with all the waves and currents and, stuff out at sea. It's like filtering out the noise to find the signal.
Exactly.
But
Then there's the Hough transform.
okay.
It's trusty sidekick. Think of it like this. You're trying to piece together a jigsaw puzzle, but some of the pieces are missing. The Hough transform can still recognize the overall picture, spotting those straight lines even when they're broken or obscured, which happens a lot with wakes and, rough seas.
Clever. It never ceases to amaze me how math can unlock these hidden patterns. But this paper also mentioned something about like deep learning and AI.
Right.
Now that's where things start sounding like something out of a sci-fi movie.
Oh, absolutely. Artificial intelligence is completely revolutionizing how we detect and analyze wakes. We're talking about teaching computers to recognize those subtle patterns, even the really complex ones, with incredible accuracy.
So do we just show the computer like a million pictures of wakes and say, all right, little buddy, figure it out?
Well, it's a bit more involved than that, but you're on the right track. We use something called neural networks, which are loosely inspired by how our own brains work.
Yep.
Basically, we feed these networks massive amounts of data, in this case, images of wakes, and they learn to identify those key features that scream ship wake versus, say, a random wave caused by the wind.
So the computer's basically teaching itself to become a wake detective. That's wild.
It really is incredible. And it keeps getting better the more data we give it. Some of
Wow.
these AI models are even designed to specifically like hone in on that unique V shape of Kelvin wakes. They're like bloodhounds sniffing out those telltale trails.
Okay, you're blowing my mind here. So we've got these amazing tools for finding these wakes, but the million-dollar question is, what can we actually learn from them? I mean, sure, we can track a ship,
Right.
but what else? Give me the juicy details.
Well, for starters, we can figure out how fast that ship was going.
Okay.
And with surprising accuracy, we're talking about using something called azimuthal displacement, which basically means looking at how much the wake appears to shift in a radar image because the ship is moving.
So even if we can't see the ship itself, we can still tell if it was like speeding away from a crime scene,
Yeah,
so to speak.
that's amazing.
You got it. And it's not just about speed. By looking at that turbulent wake, that long tail behind the ship, we can also figure out its heading, the direction it was sailing in.
It's like leaving a trail of breadcrumbs, even if the ship is trying to cover its tracks.
It's like the ocean has its own version of security camera footage.
Yeah.
This is incredible.
And here's where it gets even more impressive. Some of these new AI models are getting so good that they can even tell us the type of ship that made the wake.
Wait, seriously? Just from looking at the wake,
Yeah.
how is that even possible?
Remember how we talked about each wake having its own like unique fingerprint?
Yeah.
Well, AI is becoming incredibly adept at recognizing those subtle differences in the wake patterns that are characteristic of specific types of ships.
Okay.
For example, a giant cargo ship will leave a different wake than a nimble little speedboat.
That is mind-blowing. So you're telling me we could potentially track, like, illegal fishing vessels, for instance,
Right.
just from the disturbances they create in the water.
Yeah.
That's like something out of, like, CSI,
Yeah.
Ocean.
Exactly. It's incredibly powerful for all sorts of applications, maritime security, environmental protection, even search and rescue operations. Yeah,
But as with any cutting-edge technology,
right.
there are always challenges.
There's always a catch, isn't there? What's the hurdle with ship wake detection? Don't tell me it's aliens.
No aliens this time.
Okay.
Thankfully.
Okay, good.
Though
Well,
wouldn't that be an episode?
Right.
The biggest challenge with wake detection, it really boils down to data.
Okay.
Or rather, the hunger for more of it. You see those super smart deep learning models we're talking about?
Yeah.
They're like hungry caterpillars.
Okay.
They need a ton of information to like really morph into something amazing.
So it's not as simple as just showing the computer any old picture of a wake. They need like specific types of wake images to learn from.
Yeah, like a picky eater, but for AI.
Okay, yeah, I like that analogy.
Right.
Okay, now that sounds like a major bottleneck, but I'm sure brilliant minds are on the case, right? Any glimmers of hope in the data department?
Absolutely. In fact, this paper highlights some really exciting progress.
For optical images, the kind you'd get from like a regular camera.
Yeah.
There's this data set called SWIM.
Oh.
It's a total game changer. Over 11,600 images
Wow.
and over 15,000 labeled wakes.
Wow, talk about a wake-up call for the AI world. So that must be giving, like, the whole optical side of things a major boost.
Huge boost, but you
Yeah,
knew there had to be a but,
of
right?
course.
Things get trickier when we're talking about SAR imagery.
SAR imagery. Remind me, that's the radar stuff, right?
Right.
What's the issue there? Is it like finding a needle in a haystack of waves?
You could say that. We have SAR datasets, like one called SSWD.
Okay.
They often come with baggage, annotation errors,
Okay.
which basically means the labels aren't always accurate.
Right.
It's like trying to bake a cake with a recipe where someone mixed up the salt and the sugar.
Talk about recipe for disaster. So what are researchers doing about it? Giving up on SAR altogether?
Not a chance.
Yeah.
They're coming up with some really innovative solutions. In fact, this paper talks about using synthetic SAR images.
Synthetic, as in like not real images.
Yeah.
Are we talking about some kind of AI-generated art project?
In a way, yeah. Since getting real-world SAR data is so challenging, researchers are turning to simulations.
Okay.
Imagine creating like incredibly realistic-looking SAR images of ship wakes,
Okay.
but instead of using a real ship and a radar system, they're using computer models and algorithms.
So it's like building a virtual training ground for the AI.
Yeah.
Kind of like those simulators pilots use.
Exactly, and the early results
Yeah.
promising.
Yeah.
One project called SynthWakeSAR
Yeah.
has been generating these synthetic images and using them to train AI models, and it seems to be working. It's really quite remarkable.
That is seriously cool. Who knew you could create data out of thin air like that?
Right.
Or thin algorithms, I guess. This whole deep dive has really been an eye-opener. So to sum it all up for our listeners out there, what's the big takeaway?
I think the biggest takeaway here is that ship wake detection is like absolutely exploding.
Yeah.
It's not just about seeing a line on the water anymore. It's
Wow.
about extracting this incredible wealth of intel that's crucial for everything from, national security to protecting our oceans.
Yeah, it's amazing to think that those trails left behind by ships, something we probably like took for granted before, hold so many secrets.
Right.
What a reminder that there's always more than meets the eye, especially when it comes to the ocean.
Well said.